So hopefully you had a chance to ponder question number 2 a little bit, because there is an easier way to figure out how the multiplier is going to look without having to do all of the tedious steps we did in number 1, letter A. Now, if you didn't think the steps were that tedious, then you certainly don't have to reinvent the wheel. If you thought it was perfectly fine to just quickly find 10% of the initial value, add that number, the result, to the initial value, and then just do that a couple more times to kind of get the pattern. And then once you got the pattern, you know the multiplier, and you can figure it out from there, then that's great. Like, if you think that was a perfectly efficient method and you understand it, certainly consider the phrase, don't fix what ain't broken. But if you feel as though there could be a more efficient way, the good news is, yes, there is a more efficient way, and this is how you can think of it. It does have to do with understanding percentages a little bit, so you'll have to bear with me if this is something that doesn't intuitively make sense, but this is generally the logic that you can abide by. When we talk about an initial value, we are generally talking about 100% of whatever we're starting with. We're starting with everything that we have initially. If we are adding or increasing by a certain percentage, then consider ourselves adding to that 100%. So for example, if I was adding by 10%, then that's like saying I have 100% of my money plus 10% more money. And if we think about those two things, 100% of our money plus 10% of our money, those are definitely compatible like terms. They're both percentages. And 100 plus 10 is 110% of our money, which probably doesn't make sense as an actual number, but notice something. 110%, if you convert that to a decimal, remember to convert to a decimal, simply take the decimal, which exists currently at the end of the zero, and move it 2 places to the left. If I convert that 110% to a decimal, I'll get 1.10, which happens to be the same as the multiplier of 1.1 that I found in the previous video. So in theory, if we understand how percentages work, we actually could have predicted all along that the multiplier was going to be 1.1 or 1.10. That little extra zero doesn't really matter there. Now that's powerful, because that means we could essentially take some shortcuts now. That if we could say, well, I'm going to start with 100% of whatever I have initially, plus whatever percentage the question is giving me in the text, I can already know what the multiplier is. And that means I can go straight to making an equation. I can bypass all of that table stuff, and I can just answer questions using the equation without having to do each individual day in the table in that long, tedious process. So let's see if that pays off in question number 3. In question number 3, we've got a different bakery. This time it says Buffy's Bakery is debuting a new triple chocolate muffin. She expects to sell 100 muffins initially and expects to sell an average of 15% more each week as popularity grows. So I'm starting to draw some parallels here to see, or say to myself, okay, wait, can I use this observation I just made in question number 2? Initially, she sold 100 muffins. Now, it actually doesn't matter what that number of the initial value is. It always represents 100% of what we started with. So even though the numbers happen to be the same here, it doesn't have to be. That is my initial amount, 100%. She's selling everything she's got. And then she's going to increase by 15% more, which means she's going to add 15% more to the 100% that she's definitely going to sell at the beginning. So let's think about that. We have 100%. She's given it everything she's got at the beginning initially. And then she's going to increase by, or add 15% more, which means 100% plus 15% is 115%. Now, that number isn't my multiplier. It wouldn't make any sense. Multiply by 115 and all of a sudden you have like this insane amount of muffins. That doesn't make any sense at all. That number is a percentage, and that percentage needs to be converted to a decimal. Remember, you can take the existing decimal, which currently exists after the 5, and move it 2 places to the left. So that means my new decimal is 1.15, and that must be the multiplier. So instead of doing a whole table to find the multiplier, I can now predict what the multiplier is going to be simply by using that logic. 100% of what I started with plus 15% more would give me 115%, which as a decimal is 1.15. So now it appears I have enough information to answer question letter A, because if I want to write an equation, I need an initial value, which they gave me, and a multiplier, which I just figured out. So I can write the equation. The equation would be T of n, in our normal notation, equals 100 muffins initially, times 1.15, our new multiplier, to the power of n. Now, the reason why this is going to be so helpful is because in letter B, it wants to know how many muffins she's going to sell a year after the debut. And remember, this problem is growing in weeks. So n, as I've defined it here, is the number of weeks she's been selling stuff. You can tell why I wouldn't want to do this problem in the table. Week 1, week 2, week 3, week 4, that's just only 1 month's worth of growth. And I want to find 1 year's worth. So it may be helpful to note 1 year is 52 weeks worth of growth. And you can probably tell it's going to be really tedious to do 52 multiplications. Even if the multiplier is an easy number, like 1.15, doing that 52 times is going to get tedious. So the equation is once again worth its weight in gold. Now I can take my calculator, and any calculator with an exponent button should be able to do this, and I can use my equation. 100 times 1.15, my new multiplier, to the power of 52, and voila. That tells me how many muffins she's going to sell without having to do each individual calculation. You can round it to the nearest whole number because you're obviously not going to sell like 0.6 of a muffin. So you can call it 143,313 muffins. You can round in some other way if you feel there's an argument to be made for that. But in any case, that's how we can be more efficient. Notice in question number 3, and compare to question number 1, we hardly showed any work. We did a little bit of scratch work on the side, but we didn't make a table. We hardly used our calculator, but for one small calculation in letter B, and we didn't have to do any actual processes or algorithms, which can be so helpful. So now that you know that there's a faster way to find the multiplier, and now that you know that it can fit neatly into a geometric equation, the same structure we already know and love from the previous chapter, hopefully this will make page 14 go a lot smoother. So between now and the time you start the next video, just make sure that this makes sense. Make sure that the idea of a percentage makes sense. Make sure that converting a percentage to a decimal and using this logic to create a multiplier makes sense. And just make sure that the general logic of the geometric sequence makes sense too. If all those things make sense, then page 14 should go pretty smoothly.